Welcome you all, dear students. In this video, we are going to discuss on experiment 1, that is 2D plots for Cartesian and polar curves. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಕಾರ್ಟಿಷಿಯನ್ ಮತ್ತೆ ಪೋಲಾರ್ ಕರ್ವ್ಸ್ ಅನ್ನ 2D ಪ್ಲಾಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಪೈಥಾನ್ ಕೋಡ್ ಹೇಗೆ ಬರೀಬೇಕು ಮತ್ತೆ ಯಾವ ಸ್ಟೆಪ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. So some important steps to be followed we have listed here. First, importing library function, then setting up data, then initializing the figure, then looking into the figure, we need to name the x-axis, y-axis, and color the graph. That we have to follow later. So most important thing is importing library function. Suitable library function we have to import in the beginning. Then we have to set up the values of the dependent variable and the independent variable. Let us start with a simple program. So this is the console where we are going to execute the Python code. So ಈ ಕನ್ಸೋಲ್ ಅಲ್ಲಿ ನಾವು ನಮ್ಮ ಪೈಥಾನ್ ಕೋಡ್ ಅನ್ನ ಬರೆದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಲೈನ್ ಬರೆಯೋಣ. ಇಂಪೋರ್ಟ್ matplotlib dot pyplot as plt. So what is this matplotlib.pyplot? It is a library function that helps to create static and interactive plots, and also it helps to visualize the plots. Okay, so this is the basic library function that we must call whenever we have to plot a graph, whatever the function may be. If you are going to plot the graph, then using this library function is mandatory. Okay, that's the first step. Here, since I'm writing the simple code, I'm not using any other library function. Right, the next line, setting up the values. So as usual, first we shall give the values of the independent variable. Let me take a simple curve, Cartesian curve, y equal to f of x. The values of x may be 1, 2, 3, 4, 5, 6. Let me the values of y to be, just taking the simple example, give some values of x and values of y, then draw the graph. Let me have the values of y to be 3, 7, okay, 2, 8, 1, 9. So how many values of x are given? The same number of values of y should be given. Otherwise, there will be a mismatch in the dimension of x and y. Then you may not get the graph. Definitely you don't get the output. You get an error. So this is the simplest one, giving the values of x and the values of y. Now values of x are given, values of y are given. What we want to do? We want to plot the graph. So x ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದೀನಿ, y ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಬೇಕು ನನಗೆ? ಇವೆರಡು ವ್ಯಾಲ್ಯೂಸ್ಗೆ ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಆಗಬೇಕು. ಅದನ್ನ ನಾನು ಹೇಳ್ಬೇಕು ಅದಕ್ಕೆ ಪ್ಲಾಟ್ ಮಾಡು ಅಂತ. ಸೊ ಪಿ ಎಲ್ ಟಿ ಎರಡು ತರ ಆಪ್ಷನ್ಸ್ ಇದೆ ನಮಗೆ. ಪ್ಲಾಟ್ ಅಂತ ಕೊಡ್ಬೋದು ಮತ್ತೆ ಸ್ಕ್ಯಾಟರ್ ಅಂತ ಕೊಡ್ಬೋದು. ಪ್ಲಾಟ್ ಅಂತ ಕೊಟ್ರೆ ಔಟ್ಪುಟ್ ಯಾವ ರೀತಿ ಬರುತ್ತೆ ನೋಡೋಣ. ಪ್ಲಾಟ್ ಆಫ್ ಎಕ್ಸ್ ಕಾಮ ವೈ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಔಟ್ಪುಟ್ when we use the code plot. So corresponding to 1 here, I have value of y to be 3, corresponding to 2, 7, corresponding to 3, 2. Okay, now if I use scatter, then the output will be, to run the program, either you can use this or you can simply use the shortcut shift enter. Okay, now see, this is the difference between scatter and plot. When we use plot, it joins all the points by a line. But when we use scatter, it just marks the point y against the value of x. Okay, when we use a scatter, there is, okay, when we use plot, there is one more benefit. We can assign colors to these points. For example, now the points are in blue color. Let me have points in the red color. So just write R within single quote, then run. You get the plotted graph with red color. Okay. Then if you want the different color, let me take green color. Then I get this green. Sometimes we may need to have this instead of joining by a straight line. I may wish to join by a dotted line. See, this is the output we got. Here, the graph, I mean the points are connected by a dotted line. Just add color with G, green color I have taken G plus minus sign 2 times. Okay, this is the basic code to plot the graph. If you wish to give the values for x and y axis, let me name the x axis as x axis only, like write plt dot x label. Here you should be very careful. Sometimes you may write LABLE, that leads to error. So within single quote you have to write, or you can use double quote also, x axis. Then you can execute it. So I got the name x axis. Similarly, if you want to write the name for the y axis, then y label. Let me write it in single quote, y axis. Then you get this y axis. Then if you want to give the name for the graph itself, then plt dot title, let me take scattered graph, or let me write 2D graph. 2D graph. The output will be S. Here is the name for the graph. Sometimes some people may expect grid along the axis. Then we may write plt dot grid of open and close bracket. Yes, this is the output we get for this particular code. So we discussed how to draw scattered graph, how to draw plotted graph, and how to draw a graph with dotted lines. Next, how to draw the graph of function. If you have the values of x and values of y, yes, it's fine, we can do. Now, if I have a function, say y equal to f of x may be any function, then how to draw its graph? Let me take a simple example. Import matplotlib dot plot as plt. Then let me give the values for x again, 1, 2, 3, 4, 5. Y equal to, okay, if I want to use trigonometric function, a sine or cos, then I should use one more library function, import numpy. So this also, instead of writing numpy everywhere, we'll just write np. So that I'll call it as np. So import numpy as np. Then y equal to np dot sine of x. Now plot plot of x comma y. Then you can check, here is the graph. Here is the graph of the function y equal to sine x. So instead of giving particular values for x, we have one more option. What is that? We can give some range of values with step length. Okay, if we need to use that, then instead of giving values for x, I can write x to be np dot a range. Okay. Here the syntax is three values you have to write within this bracket. In the first, you have to write the end point, left end point, right end point, and length of each subinterval. So let me write 0.01. Now you can run this. Yes, this is the graph of sin x. Okay. Now there is one more option. Let me write it. There is, instead of a range, there is one more code, that is lin space. Be careful. It is not line space. It is lin space. Here, left hand point, same syntax as in case of a range. Right hand point, instead of step length, the third point, we will give number of subintervals we need to have. So I want to have subintervals say 100. Then it will automatically adjust the step length. See, this is the step length, you can say minus 10 to 7.5, minus 7.2, minus 5. For output, it has shown these values, but actually it has divided the interval into many subintervals, each of length 0.01. Now, instead of mentioning the length of each subinterval, I will mention how many subintervals I want. That will be mentioned, and let me run this. Yes, in the same case, I mean in the linspace case also we are getting the output. So the difference between a range and linspace is, in both the cases we will mention the interval left hand point and right hand point as written here, minus 10 and plus 10. But at this point, in case of the range, we will mention the length of the subintervals. But in case of line space, mm, be careful, it is just LINSPACE. In this case, we'll mention how many subintervals we want. We don't mention the step length. It automatically adjusts the step length. Okay. Yes, I had the graph of sin x. Yes, beautiful. Next, suppose if you want to color it, just write one more line, one more point, that is say within single quote G. So I got the output in the green line. Okay, this is the case of graph of sin x. Yes, it is beautiful. Okay. Now suppose I want to draw the graph of two functions in same code, same set of code. Let me have the same range, minus 10 to plus 10. Let me call this y as y1, or if you want, you can just retain it as y, no issue. Next line, you can write one more, that is says that z equal to np dot say cos of x. Then, if you just execute, you get the output of sin x only. If you want the output of cos x, then you have to write x comma y comma again x comma z. Now execute it. You will get the graph of sin x as well as the graph of cos x. If you just write x comma y comma z, then yes, definitely get the output of both sin x and cos x. But the output of cos x will be merged. Output of sin x is merged, sorry. So you don't get a clear picture. So for that, I should write x comma y z. So this is the code I should write to plot two graphs in the same code. Suppose you want to have one more, say 3. Let me write it as W. W equal to np dot exp of x and comma x comma w. So for this range, you are getting only this much of graph. Okay. So this is how you can write the graph of. Now suppose I want to exclude this. Just write hash before the line. I don't want the graph of exponential function. Then you get like this, because I have written x comma w here. It is drawing the graph of xp of x, that is exponential. Yes, this is the graph of two functions, sin x and cos x, in a same graph. Now, suppose I want to plot the graph of two functions, that's fine. But I want to mention which graph is representing the which function. Here I don't know which one is the sin x or which one is the cos x. So for that I had to use one more command, that is label. Let's do it. So x comma y comma label. So for this I had to give a name, that is say sin x. There is one more line to be written. Okay. X comma z comma label cos x lt dot show. Yes. Did you identify any difference here? No. Though I labeled the graph of sin x and cos x, I did not get any difference in the output. For that you had to use one more command, that is plt dot legend s. This will make the difference. Now just see the output. See, this blue line is representing the graph of sin x, whereas this orange color line is representing the graph of cos x. Okay, this is how you have to plot the graph of two functions in a same code. Let me write one more simple example. Import matplotlib dot plot as plt, import numpy as np, then x equal to np dot, will give linspace of let me take the range, some 0 to, okay, let me take 4 with 100 samples. Okay, plt, instead of writing y explicitly, so I'll write within the code only plt dot plot and the value of x, that is already mentioned. What is y? I type y equal to x, linear, then label it as linear. So I'll get the output, the linear line. Okay. Then plt dot plot. Let me take x. That is the independent value, independent variable, values of the independent variable is. Then x square. Okay, it's not power 2. It is for square double star 2. I had to write. Yes, label. This is a quadratic line. So I'll write quadratic. Then plt dot plot x comma x cube. Some students will write x double star 3. That is not the way of writing x cube. I have to write x double star that rises the power to 3. Label it as cubic. Then plt dot legend, run it. I got this. This is the output. Okay, but we still write one more code, that is plt dot to show, that instructs the interpreter to show the output. Sometimes it makes no difference, but still practice to write this plt dot show. So this is how you can plot the Cartesian curve using Python code. So next is about, if you wish to plot the graph of polar curve. What is a polar curve? A curve of the form r equal to f of theta. Then how to plot such curve? Let me take a simple example. Let me uh, draw the graph of a circle. Okay, circle means we need the values of r and values of theta. R, it's a radius. It should be a fixed number. You cannot draw a circle with arbitrary radius. It's a fixed number. Then theta you can vary from 0 to 2 pi. So as usual, the first command is import matplotlib dot plot as plt. The first line import numpy as np, an important one. Here, first you have to set up the axis to be polar one. Okay, you have to instruct the interpreter that you are going to plot the polar curve. So this is the mandatory line you have to write plt dot axis. What type of axis you are using? Projection equal to polar. Okay. So here the Python interpreter will understand that you are going to plot the polar graph of a polar curve. So plt dot axis projection equal to polar. Then give the value for r equal to say 3. Any number you can give. It is a fixed number, right? You have to mention here. Then you have to give the range for theta as we did in the previous case. X equal to np dot a range of left hand point, right hand point of the interval, then step length like that. Here I'll write RADS equal to np dot a range left hand point 0, right hand point np dot pi. So 0 to 2 pi, right? Let me write within a bracket 2 star np dot pi. So here wrote the lower limit, here the upper limit. Then you should write the step length. So let me write 0.01. Then so the range for the angle is given here. Then you have to plot the graph, right? For that I will use the loop, that is for loop. For RAD, or you can, if you want, you can write theta. Let me write theta. Let me see what will be the output. See, this theta should vary in the range of RADS as we had defined here. Okay, when you use loop, that should end with a colon. PLT for each value in the above range, you have to draw. Here we don't write plot. That is in the case of Cartesian curve. In the case of polar, we write polar theta r. Want any color? Let me give the color. Let me not give any color. Then PLT dot title, if you wish to have the name circle, PLT dot show. Run this. We see what will be the output. See, looking here, this symbol shows that the interpreter is executing the program. It is still running. When you have this icon, don't do anything. Just wait for the output. It's still executing the code. If it still takes too much of time, just stop the process by clicking on this, then run it again. Let me give some color to this. Maybe the error. Stop the process. Then I'll execute again. Yes, here we got the output. Okay, so this is the circle with radius 3 units. 0.5, 1, yes, here it is mentioned. Sometimes what the common mistake happens is this. So instead of shifting this line PLT dot title circle to the left end, we'll write like this. Then if you run this, the output will be like this. Get so many circles. Still many circles are getting created. Okay. So why this is happening? What is the error? Let me look into this. Say for theta in RADS within this range. First theta will be 0. When theta is 0, the graph will be plotted. See, you can look into this location. Here is the color, blue color. So this point is marked. So this line will be executed. After executing this line, the immediately this line will be executed. So the naming is done, circle, and output is displayed. Then after this, it again goes to this line. It takes RADS to be now. First, it will be 0, then it will be 0.01. Step length is 0.01. So it goes to 0.01. Then again, it plots a graph with theta equal to 0.01. You can observe here. Then plotting will be done and output will be displayed. Then again in the next step 0.02, 0.03, 0.04, 0.05, 0.06. You can check that for each such point the graph is plotted and output is displayed. Here have some other value. Okay. So totally 2 pi divided by 0.01 number of circles are drawn. Okay. So instead of writing PLT here, just write. Then what will happen? For theta in RADS, first initially theta value will be 0. So the point at 0, theta equal to 0 will be marked. Then after marking that, again it goes to the previous line here. So it marks the point at 0.01, then 0.02, then 0.03, then continuing this till 360 degree or 2 pi. All the points will be marked. Only after that it comes to execute this line. If you write this PLT in a same spacing with the line PLT.polar, then the graph for each point will be displayed. Instead of that, if you write like this, then points will be marked corresponding to each value of theta. The final output will be displayed. Then in that case, the output will be, as we saw, a full circle just in a single graph. So now it is still executing. We shall let me consider one more example. Plotting of cardioid. Okay. Cardioid r equal to a times of 1 plus cos theta. You know the equation of that. So let me discuss how to plot the graph of cardioid. So it is still executing. Okay, let me write the code for S. I got the output. Okay, this is the output of the circle. Next, cardioid. Cardioid r equal to a times of 1 plus cos theta. Again, a is some fixed number. You have to give the value for a, and theta is the variable. We have to write as we did in the case of circle. Okay, first line import matplotlib dot matplotlib dot plot as plt. Then import numpy as np. Let me import math to import math. First, you have to set up the axis. PLT dot axis projection equal to, in single quote, polar. Okay. Then give the value for A, or you can write the value. Okay, let's write R first. R equal to, let me not write R, otherwise I may need to define the symbol. So I'll give the value for A. Let me take A equal to some 2. Then range for theta, that is RADS equal to NP dot range 0, 2 star NP dot pi 0 to 2 pi step length 0.01. Then for RAD, let's take theta. For theta in rates, okay, see the cursor. I got cursor here because I did not write the colon there. Now, after writing colon, the cursor is moved to different position. So for theta in radius rates, I had to plot LT dot polar theta, comma a times of, it may be a bit confusing. Do one thing, let me define R. R equal to a star 1 plus cos of theta. Right. Now you can write tilde dot polar theta comma R comma single quote, let me write blue. Then PLT dot title cardioid. Then PLT dot show. Okay, let me execute this. Cardioid. Okay, cause is not defined in P dot call. Let me execute this and see the output, or output is going to display. So after this, next is plotting of rose curve with even number of petals. That you have to use A equal to absolute value of cos b theta. You can practice it, I think. Let me get the output of this. With that, let me wind up this video. Yes, this is the output of cardioid. Okay, so this is how we have to I have to plot the graph of various polar and Cartesian curves. Using this idea, try to practice few more examples so that you get expertise in plotting of 2D plots. With this, the experiment 1 is over. In the next video, let us discuss experiment 2.